My name is Eric.
My name is Tim.
My name is Julia.
My name is Kiki.
And this is
AIDE
OnShape. Okay, so OnShape is Agua Clara's frontier design team. So we use a cloud-based CAD service called OnShape to design all the different parts and components of the Agua Clara plant. And we've gone through many iterations and we finally determined that OnShape is the best and the most accessible to everybody. So some of the big revelations we've had over the last few years is getting closer and closer to Ethan Keller, who shows us his amazing OnShape practices and principles to follow. So this semester we've been working through all of his notes and documentation on how to correctly CAD things in a way that's readable and understandable to anyone who wants to see it, which is a big proponent of being open source, being legible, and not having poorly named items in our documents. Another big component is connecting geometries, where we're redesigning our plans now to work much better off minimal variable inputs. So we're trying to work with AIDE feature script and AIDE Python to make very few inputs that you could do through feature script code to allow us to make our plans very easily and very specific to the regions that need them. Another big component is a new tool called SuperDrive, which allows us to derive over not only parts, but also variables. This has changed most of our designs because now instead of just importing different parts and different shapes that we've already designed, we pull over every single variable and variable configuration into our new documents. And that allows us to build a telescopically increasing document where we start off with individual parts, we start working towards bigger components, and then by the very end we have one document which pulls from a few other documents into a final product. Another big component has been making sure we keep organized. That's one thing we've been focused on, is we're renaming all of our mate connectors and all of our parts so we have nothing that's unlabeled and hard to understand or decipher. Where in the past we didn't focus too much on this documentation aspect, and it caused us a lot of issues when transferring files between programs and moving towards new projects. So our configurations are a huge part of what we're designing, because those go along with the variability derived that we've been using with SuperDrive. So for all of these, we need to make sure that our configurations are not based off random calculations or random numbers. They have actual meaning and connections to the overarching project. And we need to make sure that when we're importing entire variable prefixes, which is a collection of variables into new aspects of the plant, that we keep everything cohesive and legible and makes everything much easier and much more clean. And if we need to go back, which we often do, it's much easier to make the changes that we need to make. And introducing pipeline.
Okay, so Pipeline is a tool that the summer team developed for us to generate pipes more easily. So it allows us to just draw lines in sketches, and then we use Pipeline to connect all the points in the line and then make a pipe out of those. Right now, Pipeline is a little iffy because we can't adjust the pipe sizes, but we've been working on that to redo the CDC. So right now we've been working off of Tigran's model of the CDC and trying to replicate that using SuperDrive and Pipeline. And we have, I've been working on the outside component of that, so connecting the CDC to other components of the project. And this is the work that I've been trying to do and generate the pipes in appropriate parts.
Okay, so for the piping, I've been working on the Chem Tank piping. So as you can see, there are a lot of Chem Tanks and there needs to be a lot of piping through, if you can see through the translucent view of it. And so as you can see, there's pipes that need to be created to connect the two together and to go through the Chem Tanks. So I've been working on the piping, but I've run into a few issues. One is that the default size of the elbow is too large for the pipe, and so it goes into the ground, or it just doesn't fit the right dimensions. And so I originally thought that I could just create a new hole inside of the Chem Tank, but I found that since it's super derived, I have to kind of create a new chem tank, and so I was using tangent plane to create holes with the chem tank, but I'm sort of having some issues with that, so that's what I'll be working on in the future.
So I've been working on creating mostly the floor for the chem tanks, and then the assembly between the chem tanks and their actual floor. But I ran into some issues when I was using the past document or drawing for the floor, because as you can see, it looks very messy, and there's a lot of different dimensions and configurations that go into it. So whenever I ran into an issue with maybe the tanks intersecting each other, then it was really hard to go back into this document to figure out where the issue came from. Additionally, there was uneven spacing between the tanks. So obviously in this drawing, the smaller tanks have a good distance between them, they don't intersect. But then when you go to the larger tanks are first intersecting each other, but then they're also intersecting with the smaller tanks, because they just used a wrong equation to find out the spacing between the tanks, as I have shown on the top. And also to put the location of the tanks into the chem tank, they just use X and Y coordinates, which I found was very difficult to figure out when you tried to change the location of them, because you had to go into each X component, each Y component of each tank, and it was a lot very time consuming and also confusing. So I wanted to fix that, and this is what I came up with. Even though it still looks messy, it makes a lot more sense, because I have most of the configurations just based on the outer diameter of the chem tanks, and also wall thickness and wall length of the whole entire structure. But by making it easier to look at, it made all of the formulas that went into the configurations much more difficult and longer, as you can see by the formula that I included. But that specific formula was just to have even spacing between all of the tanks and the walls, so they won't intersect each other, because it's just based on the outer diameters of every single tank. And I also used a similar formula for the position of the hole that connects the pipes from the chem tanks to the CDC. And I used just an equation that includes the outer diameter of the tanks. And this will make it so that it always adjusts to the size of the tanks and also the width of the floor, so that it will never have any issues of intersecting with the tanks or intersecting with the floor in the wrong way. So that has been the main work I've been working on. And then in the future, or that's what it looks like currently now that I've fixed it. As you can see, I was naming all of the SuperDrives so that we, as Tim was saying previously, that we keep track of them and we can go right into them and see exactly what they're dealing with. So it's important for us to stay organized in that aspect. But what we're going to continue to look at with the chem tanks is how they connect to other parts of the plant in general, but also the CDC. I included a translucent view of the chem tanks to show the pipes that are going to connect the chem tanks to the CDC. And we're looking at mainly where the red circle is, because that's the most important part that connects the chem tanks to the CDC and the rest of the plant that we really need to focus on. Thank you.